There. This is the second video in my series on different models, focusing on the number line. And in this video, I wanted to look at how the number line is a useful model for absolute value equations and inequalities, something that my students have historically struggled with. Now, I'm assuming in this video that students know how to solve basic linear equations and inequalities so that the mechanics of doing the equation itself is not the issue. The issue is how do we present the number line? So the question is, how can we use the number line to build understanding of absolute value? And for me, this comes down to how we define what absolute value is. The absolute value of a number is its distance from zero on the number line. And we want to be really clear that the number line is part of how we are conceiving of what absolute value is in the first place. And we would do that right when we are first presenting the symbols for absolute value and that vocabulary. What do we not want to say, or do not say the following? Okay, and there's just stuff here. That absolute value makes a number positive. Now, this isn't necessarily incorrect, although it doesn't take into account the number zero, which the next thing also does not take that into account. So absolute value makes a number positive. We don't want to define it that way for students. It has no context, like, okay, sure, fine, we've got this symbol and it makes numbers positive. The absolute value is always positive. Now, this is sloppy and incorrect. It's not incorrect in a way that I have found causes massive misconceptions later on, but it is not correct because the absolute value of zero would be zero, which is not a positive number. So this is a sloppy thing to say. It might be useful at times, but it's not entirely accurate. Now, if you're wondering, okay, well, what would I say instead of that? I would use this word here. That absolute value is always non-negative, and that's going to incorporate the zero in as well. And then the last one, that absolute value switches the sign. Now, this is objectively wrong. That is not what absolute value does, and the moment you say the absolute value of 3 or something, if a student has that misconception, they're going to tell you the absolute value of 3 is -3, and I see that fairly frequently. I would say a measurable amount of the students that I see in Algebra 2 on the regular do have that misconception, which might have come from someone saying, well, it's going to switch the sign, and then students carry that to its natural conclusion. So we don't really want to be talking about absolute value using any of those phrases. Okay, so consider this. The absolute value of -3 is equal to 3, not because absolute value makes a number positive, okay? That is not necessarily incorrect-ish, but because it is 3 units away from 0 on the number line. So when I am presenting this to students, I draw out my number line, and then I locate the -3, and we'll have students tell me how far away is it. Well, it is 1, 2, 3 units away. And illustrations that I would use is, say, a step counter. A lot of us have a step counter on a watch, or our phones track our steps. And the step counter doesn't care which direction you're going in. It just simply cares like how many steps you take. And so if you were standing at the -3 and moving towards the 0, then you would walk 3 steps. And this actually will also avoid another misconception students have, which is where they start to count the tick marks on the number line instead of the spaces. So they will end up counting, oh, there are 2 tick marks in between. I haven't really had students do this with absolute value, but I have had them do it with other number line kind of problems. So the absolute value of -3 is 3, not because absolute value makes a number positive, but because it is 3 units away from 0. Now, using this definition is going to translate smoothly into absolute value equations. And so I've got a couple of absolute value equations up here. So we'll start with this one. I always start with just the absolute value of x, try to keep it simple for students at the start. And so we could actually sketch that out. So the absolute value of some unknown number is 5. Well, what does that mean? And we bring it back to the definition. It is 5 units away from 0 on the number line. And so we would ask students, okay, well, what's 5 units away? Well, we've got 5 over here to the right and -5 over here to the left. And both of these would be 5 steps away if you were, again, like walking with your step counter. And so we have 2 values that would make it true. X could be equal to 5, or X could be equal to -5. And one of the conversations I've had with other math teachers a lot is, do we say or and? It depends on how much you want to get into like sets and whether we have like these are 2 separate sets or we're like, yeah. I use the word or, so I would just say x can't be like both of them at the same time, but both 5 and -5 are solutions. So I mean, we could kind of argue that either way. Okay, looking at the next one. So this is where I will see students do some really weird things that possibly come from poor definitions of absolute value. So if you try to define absolute value as, oh, it makes all the negatives positive, then this is what students will sometimes do. They will say that the absolute value of 2x minus 6 is equal to 2x plus 6. And they will just do that. Okay, so they will say 2x plus 6, and their reasoning behind that will be, oh, well, absolute value takes negative numbers and makes them positive. And you can totally see where if that's the way that absolute value has been defined for them, then that makes this a very logical thing for them to do. Oh, okay, the -6 becomes a +6, and then they just go ahead and solve the equation from there. And so so let's take a look at what it does when we define this using the number line. In this case, then we are saying the distance from 0, okay, because that's what the absolute value means. So the distance from 0 is 10. And so coming over to our number line, we ask ourselves, okay, what's 10 units away from 0? Well, we have 10 on the right and -10 on the left. What has a distance from 0 of 10? Well, it's the thing in the absolute value. So it is 2x minus 6 and 2x minus 6. So in other words, the 2x minus 6 is either equal to 10, which would give it an absolute value of 10, or it would be equal to -10. And that's going to allow students to set up both of their equations. 2x minus 6 is equal to -10, or 2x minus 6 is equal to +10. Then we would add 6 to both sides and divide both sides by 2. Add 6 to both sides and divide both sides by 2, and we get x could be -2 or x could be equal to 8, and both of those would give us an absolute value of 10. And you can actually see how the distance from 0 plays itself out when you like sketch it on the number line. Now, the last one gets into some of the more mechanics of solving absolute value equations, which I always tell students you need to isolate the absolute value first. Not that you couldn't figure out a way to do this, but like isolate the absolute value. That's a pretty good principle when they're solving radical equations or exponential equations and that sort of thing as they move forward, is before you try to deal with the absolute value, make sure the absolute value is the only thing that you're dealing with. So in this example, we would add 2 to both sides. And I wanted to make sure that we did look at this in this video, where -2 plus 2 is 0, so the absolute value of x plus 4 is equal to 0. Well, what does that mean in terms of the number line? It must be on the 0. So when we look at this, if its distance from 0 is 0, then it must be on the 0. Therefore, the x plus 4 is on the 0, and then subtracting 4 from both sides, we get one solution, because in this case, we're not moving to the left and the right. So that really gets at the why we don't say that it's always positive. And because kids will get all messed up there, because now like my value for x is actually negative, and yeah. But if we are really framing this in terms of it's the distance from 0 on the number line, and we're using the number line as this tool for picturing what absolute value is, now all of these just kind of fall into place, because everything is like pictured as its distance from 0. Now, inequalities, this will also work with inequalities. So in this case, we are saying the distance from 0 is less than 3. And so looking at the number line, here's my 0, and we say, okay, well, if I walk to the right, the distance that I walk to the right has to be less than 3. So I can move to the right, but I have to stop before I get to the 3. And you know, for a lot of students, if you've taught inequalities, we recognize that that is an open circle. So it could be like 2.999999, like whatever. But it can't actually get to the 3. And then we can go in the other direction. You know, what if I am walking 3 steps, but I'm going in the other direction? Then the same thing would happen over here. And what is it that has the distance from 0 of less than 3? Well, it is x minus 5. Therefore, the x minus 5 must be sandwiched in between the -3 and the +3. And so we can actually use the number line. I love using the number line here because we can mirror it. Just like from the number line, you can actually take like the shaded part, and like the -3 and the 3 are still the bookends on that. And again, I said at the beginning of this video, we are assuming, like in this video, that students know how to solve this kind of inequality. So we would add the 5. And what do we get here? 2 is less than x is less than 8. And so, yeah. So the solution set to that would be anything between 2 and 8 would make that inequality true. Now with the greater than, this also works. So this is similar to the other one. Like I said before, you want to make sure that you are isolating the absolute value. So before we deal with distance from 0, we want to make sure that distance from 0 is the only thing that we are looking at here. And that's not the case here. We have a ×2 right there. So the first thing we want to do is undo that multiplication by dividing both sides by 2, so that we have the absolute value of x plus 1 is greater than or equal to 4. And so let's take a look at what that means on the number line. So distance from 0, so we've got distance from 0 is greater than or equal to 4. So starting at the 0, if I'm walking to the right, I want to walk a distance greater than or equal to 4. And so that would be the solid circle and anything greater than that. So if I walk 5 or 6 or 7 steps away, and then the same thing happens walking in the other direction, I want to walk a distance greater than -4. And that can really mess with the kids, because what I am shading in is this less than region, but I'm talking about a greater than distance. So you looking at it as like the number line, you're walking along the number line, and it actually opens up a great opportunity to discuss like how direction matters, and when direction does not matter, but that's probably science nerd me kind of coming into that there. And so we would ask ourselves, all right, well, what is it that has this distance of greater than or equal to 4? And it is the x plus 1. And so x plus 1 can actually be in 2 different sections here. And now we're going to invoke the less than. So x plus 1 is less than, which would be awesome if I wrote less than. Try again, is less than or equal to -4, or x plus 1 is greater than or equal to 4. And of course, we would subtract 1 from both sides. So x is less than -5, or x is greater than 3. And that gives us our answer. And another thing I like about doing this on the number line is I will tell students, hey, if you are shading in 2 different sections of the number line, then you're going to have 2 different inequalities. Because the other thing students will do is they will try to be efficient, and they'll try to merge this into one thing. So 3 is less than or equal to x, which is totally fine. And then they'll just try to put this on the other side of it. So x is less than or equal to -5. And what I try to tell them is, hey, what you just did there was you told me that 3 is actually less than or equal to -5, which we know is not true. And if you're, again, using the number line, you can see that this would be backwards from how those numbers are on the number line. Unlike the one above it, where your 2 and your 8, like you could actually plot that on the number line and shade in between it. You would not be able to do that here, because you'd have to switch the order of the numbers. So I think it can help avoid that misconception as well. So what do we want to avoid? We want to avoid teaching procedures with little or no context. And I have had students who have come to me like post Algebra 2 tell me something like this. Well, when it's a less than, we set it up like this. Like, so I think I had on the other page, -4 is less than, x plus 2 is less than 4. And that's it. Just if it's a less than, then that's how I set it up. And when it's a greater than, I set it up, this way. X is less than -4, or x is greater than 4. And here's the problem with that. As soon as the student says that, this student might be able to arrive at the correct answer, but does not understand what absolute value is, or why the inequalities are set up the way they are. Like, somebody has just simply given them a procedure. If you see this symbol, then your answer will look like this. If you see this greater than symbol, then your answer will be like this. And the student does not know anything about the distance from 0, or why the resulting values of x are going to give them values that make the inequality true. So we really want to try to avoid that. We don't want right answers without right understanding. It's a very tempting shortcut to take, but is not in the student's best interest in the long run. And we also don't want to enable misunderstandings about absolute value, such as absolute value switches the sign. We want to really find out if our students have those misconceptions and get rid of them at the outset. So like, there is no what I call like math voodoo of switching signs around. It's about the distance from 0 on the number line. And we're using that model, and we're using that tool to picture what it is we're doing when we're solving these kinds of problems. Bring it back to the number line. Use the number line as a reasoning tool. Encourage or even require students to sketch out where the solution is on the number line. I have found that I'll do it in class, but my students can be very resistant to doing it themselves. But something I'm exploring as a teacher is actually requiring students to do it. So make them sketch it out. Make them go through that thought process instead of trying to jump to a procedure that's going to get them there faster. And questions questions on quizzes or tests or homework problems, if you don't want to put it on a test, require a homework problem where students have to draw out on the number line what it is they're trying to do. And incorporate real life instances where this concept is used. So I like bilateral tolerances, which is where you will have some kind of like a hole in a piece of wood, and it'll say the diameter is 2 plus or minus like 0.5, which is a great example of like 2, and then you're going to go left or right by the same amount. Now, whether you'd use absolute value in that context, debatable, but it is an example of where we're moving like left and right, and we don't necessarily care which direction as long as we stay within a particular like value range for whatever we're doing. And so that can give students a little bit more context and grounding into what they're doing. And because like a diameter or a tolerance is also a very physical thing that you could actually like draw out and make a picture of, it reinforces that as a tool as well. So I hope this helps with some ideas for how to use the number line and how to apply it to absolute value.